Designing for mass flow discharge outlet. In summary, mass flow is our first in, first out flow pattern. With mass flow, the entire mass of material in the storage bin comes down as a single body. All of the material in the storage bin is in motion. And the indication that you have mass flow is that material is sliding on the bin walls. And in order to get material to slide along the bin walls, the sloping walls of our bin need to be sufficiently steep. But is having sufficiently steep bin walls enough to have a reliable mass flow storage and feed system? The answer is no, emphatically no. What is happening at the discharge outlet is critically important. First, the outlet itself needs to be greater than the bulk solid's bridging dimension. The bridging dimension is a minimum diameter for a circular opening and a minimum width and length for a rectangular discharge opening. If the discharge outlet is not bigger than the bridging dimension, then the storage bin will be susceptible to chronic bridging over the feeder. Essentially, good bin design is a game with gravity, and we need to make sure that gravity is sufficient to break the strength of the arch at the outlet. Now, the bridging dimension for a particular bulk solid is determined by a number of factors. A critical one is the shape of the bin. And there are a variety of bin shapes out there. Plane flow, conical, transition, chisel. These are just a few examples. And this bridging dimension, it varies from shape to shape. Ultimately, the bridging dimension is determined through a bench scale test, the shear test. Another critical factor to having a reliable mass flow storage and feed system is that the discharge outlet of the storage bin needs to be fully effective. And what I mean by that is that the material needs to be emptying evenly from the full width and length of the discharge outlet. Remember the definition of mass flow. The entire mass of material in the storage bin comes down as a single body. All of the material in the storage bin is in motion. And the only way that you get that is if material is emptying equally from the full width and length of the storage bin's discharge outlet. And this is where a feeder such as the KamengoU feeder comes in handy when you are designing for mass flow, because it pulls material evenly from the storage bin's discharge outlet. Good bin design is about making confident, purposeful, science-supported decisions and making a good decision on the bin outlet dimension, and the choice of the feeder is critical to delivering a reliable mass flow storage and feed system. To learn more about why bins plug and the theory that underpins good bin and feeder design, visit the KamengoU website and download our white paper.